Okay, so the first law of logarithms we're going to look at is this one here. Okay, quite simply, when you add two logarithms together, okay, they've got the same base. Okay, it's equal to a single logarithm, okay, of the same base. But the terms here have been multiplied. Okay, we've got the product of x, y here. Okay, and that will work regardless of x and y. As long as x and y are positive, it'll always work. Okay, so how do we show that? How do we sort of prove this sort of statement here, this result here? Well, first of all, look at what we've got here. We've got log of x, log to the base a of x, and we've got log of y to the base a as well. Okay, and you know, you're adding them to give this. Well, ultimately these are equal to something, aren't they? Log to the base a of x is equal to something. Log to the base a of y is equal to something. They're both equal to like powers, isn't it? We've seen before. Okay, so what I'm going to do is I'm going to say, look, let log to base a of x equal to something. In this case, we'll use the letter m. Okay, I always use m in this proof. Okay, m just represents whatever this is. Okay, it's just a letter. Okay, general letter to represent this. And of course, well, log to the base a of y is equal to something. So let's say that equal to n. Okay. And then when you've got these then logarithms equal to something, okay, I've got that one equal to m. Okay, we can rewrite this, of course, can't we? Because if you think about the way logarithms work, okay, you can get rid of a logarithm, can't you? You can sort of unlog it. You can get rid of it by swinging the base back over, as we saw in the previous videos. So if I swing that base back over there, okay, I'm left then with x, okay, and then we've got the base here to that power. Okay, so we've got that. So if you're unsure of that process, you just need to look back at the previous videos. But ultimately, I'm just rearranging the equation here. That's what you need to think of, and we do that by taking that base over to the other side. The logarithm disappears, and the base then to that power. Okay, and we've got x equals there. Same here. Okay, so let's swing that base over here. Okay, and the logarithm disappears, and we're left with just y on this side. The base is swung over, and there's a to the power n. Okay, so we've got two now expressions for x and y. And then let's look at the result. Of course, the result of adding these two logarithms is the single logarithm with the product here. So the product, that xy there, is what I'm going to look at now in terms of my proof. So let's look at what xy is going to be equal to here now. So xy, now of course times in these, yeah? Well, we've got an expression for x and an expression for y here. So because I'm timesing them, I can use these now. So instead of saying xy, I can actually times what I've said x is and what y is together. So a to the power m times a to the power n. Okay. And then when you see that here, you can simply think back to GCSE work in terms of indices, yeah? Rules of indices. Now, when you've got the same base here, okay, think of rules of indices, and you're timesing these two terms together. You add the powers, don't you? So I can rewrite that as a to the power m plus n. Yeah? Okay, so you are adding the powers simply because of indices. Okay, that's what we always do, don't we? When we times in terms, we add the powers. Now, when you look at this here, okay, we could actually then rewrite this as a logarithm, can't we, if you think about it? Because I've got xy equals to a, which would be my base, to this power. Now, my power is m plus n. So what I can do now is if I wanted to work out that power, for instance, yeah, if I wanted to work out what m plus n was, that power, I need to take that a over to the side, and I do it by swinging over, and it creates a logarithm, log to the base a of that xy, and that will equal to this power here, m plus n. But of course, I've already defined what m and n are. M is just this, so I'm going to rewrite this now. Instead of having m there, I can write what m is, which is log to the base a of x, plus then it says, and then n then, which is this log to the base a of y. And I proved my result through that process there.